This was our engineering design process, but because of the very loud background,
If they're bigger, the motor.
we thought the best choice was just to voice over it. Our engineering design process had a few issues because of the claw being too heavy. Due to the motor and the individual pieces, the arm couldn't lift up the claw. In order to fight this, we added a second set of gears for another arm for extra support. At first, we tried to set big set of gears connected to the motor, but this decreased our torque and increased our speed. With more torque, we can get the arm to pick up the claw easier, so we switched the gears, sacrificing speed for torque. Our video of showing the robot in the field doing its task crashed, so we would just be explaining the code.
At the beginning of the code, the def check is to define all functions within the code below constantly.
The code tells the optical sensor that if it reaches the range from 230 to 250, it should print the color blue and make a siren sound, with 230 to 250 being the hue codes for the color blue.
Tells the optical sensor that if it reaches the range from 100 to 130, it should print green and make a noise. 100 or 130 is the hue codes for green.
The code below tells the optical sensor that if it reaches the range from 0 to 30, it should print red and make a noise. 0 to 30 is the hue code for red.
At the end of this code portion, there is an else statement with exit error. What this will do, if it does not detect any color at all, then the function will keep checking with the def check.
In the real world, superheroes with capes aren't flying around. Instead, they are programmed machine coded to complete tasks effectively, and they are known as robots. To begin with, robots are used to effectively enhance the results of a patient. The existence of robots in the medical or healthcare area provides patients with advantages of swift recuperation, decreased prices, assistance with carrying out everyday duties, and develop healthier states of mind for patients. In addition, robotics can not only capture the attention of, but increase educational experience of students. With the use of robots, students are exposed to interactive technology and opportunities to educate their knowledge in coding and engineering.
The choice of majoring in the complex field of engineering opens individuals to a world of possibilities for careers. In a handful of engineering majors, the most prominent in society consist of civil engineering, chemical engineering, mechanical engineering, electrical engineering, industrial engineering, aerospace engineering, bioengineering, energy engineering, and the list is endless. However, if someone wishes to enter a career that revolves around robotics, majors such as mechanical engineering and electrical engineering should be the sole concentration of studies. The Mesatron's robot, called Bottomless Prime, carries out the function of autonomously detecting colors and responding via sound and suppressed movement. Bottomless Prime has the capability to perform these functions successfully by effectively reading code and the overall construction of the robot. Bottomless Prime can also be trans-operated via controller and code that is written by our coders on the Mesatrons. This robot can be identified through its rich appearance of colors, such as its red gears, the gray metal, and black tires. However, these colors are consistently present throughout the whole robot. Moreover, Bottomless Prime has a feature to securely grasp the disc via its claw and secure foundation to properly allow movement. Without a doubt, Bottomless Prime's claws can shift upward and downward, as well as open and close, drive forward, backward, left, and right, while simultaneously illustrating its notable colors.
Pose with the